We are VA Plus, an innovative BIM consulting firm located in Denver, Colorado, with over 15 years of experience working on projects around the world to bring designers and clients' visions to fruition. Contact us today about our services, such as BIM modeling, BIM management, as-builts and conversions, scanning and point cloud services, custom solutions, and beyond. Learn more at vaplus.us. And thank you for watching. Hi, we're going to use generative design to create an initial layout of student desks for this room, which then later on we're going to adjust a bit and then validate with the workspace density planning tool in order to come up with a more robust classroom layout that enforces social distancing. So this is the family we're going to be using for this. This is a modification of the workspace density planning tools social distancing family, which is compliant with the 3-foot social radius that is intended for students. It also includes a student desk to bring directionality into the output that it generates, so that way you can see what direction students are facing. Okay, we're going to go ahead and run the generative design tool on this. We're using a modification of another existing generative design script. We actually worked from this one to start with to generate rows of desks, because this also generates implicit circulation paths, which is something that we do need to represent inside the in our results for our layouts, since these are going to have access to teachers and also access to the chalkboard and other areas of the room. On this type of situation, though, since we're mostly concerned with the actual space filling and the geometry, Optimize is not always the best option. It produces some stuff, but you'll get better insight from Randomize. But we'll run it through Optimize anyway, just because it shows kind of what the tool's doing and gives me an opportunity to sort of describe how our script modifications are working with it. Let me go ahead and just run this then. So this is the results, simple results from our workspace layout script, or our version of the workspace layout script. And in these, you can see that it is generating a bunch of stuff, but it's also exhibiting convergence. And this is part of the problem with running it in optimize mode, is that it will tend to converge on all of these things because it thinks it's found, quite rightfully, the correct number of desks, and it's prioritizing the other possible layouts for that correct number of desks. So it optimized for 25 desks, and now it's doing variation on all of the other factors, which is actually the opposite of what we want, which is why we want to use randomize, since this would be an ideal situation for a case where the other factors like distance to exits and views to outside are more important than the arrangement and the geometry of what you can pack into the room. For our case, we're actually not concerned at all about average distance to exits, since it's not very far. It's a very small room. And we're not concerned about views to outside or views to chalkboard in this case as much. It's still a factor, but it's not weighted as highly. So in order to achieve this, what we're going to do is we're actually going to run this in randomized mode. So let me go ahead and run this here. This is in randomized mode. This is a lot simpler. It's not going to be trying to optimize for a certain situation. It's just going to just generate possibilities. So let's go ahead and generate this and see what it comes up with. As you can see, the results here are a lot more diverse in the sense of they're not really converging anywhere, which is exactly what we want to see for this particular application. And so in this, we are seeing a variety of different layouts that are occurring, that are emerging from this. Different kinds of row layouts, multiple rows, and we're also seeing a lot of stuff that's not orthogonal. And this might seem a bit counterintuitive. It's sort of mathematics finding a way to evolve a staggered layout. So a lot of these ones that are non-ortho, or they're doing these multiple rows with some stragglers out here. At first, I was thinking that these were probably just junk ones that was generating, but these are actually a lot more beneficial than it seems. This is actually getting closer to kind of a hexagonal tessellation of desks, which is the ideal packing situation for us. If we didn't have to worry about circulation. So if you do bring in circulation, you're going to end up with a situation like this. If you have to factor in circulation on top of the hexagonal tessellation. Anyway, enough about that. Let me actually show you one. There, boom. So this is one of the best layouts it's generated to me, in sense of providing insight as to what we can do with this room. And in this layout, we have students are facing opposite, which is great for not projecting into each other, but not so great for visibility to a central chalkboard or a central location in the room. Everyone's going to be craning their neck in different directions, or they're going to be having to turn around completely, and they're not going to be facing their desk anyway. So this isn't the most ideal layout, but it is a layout which gives us a lot of insight as to how the room may need to be modified to enable it to have better access to the chalkboard. So what we're seeing in here is that along the long edges of the room, those are actually preferential for students to be facing in this type of layout. And this type of layout does give us a lot more in terms of capacity than we would get for layouts that require access to the short ends of the room for visibility. So from this, we have suggestions now. We now have insight that we can now communicate to the building operator and to the school, saying, hey, if you guys bring in a whiteboard, or if you move the chalkboard, maybe disassemble it or something and move it over to a different wall, you're going to have a higher capacity, and you're going to be able to support a larger number of students with adequate social distancing, and that this will be more efficient. So basically, generative design has given us insight. It's a layout that tells us where to go next. And a lot of the generative design application that we've had for this particular situation with the classroom layouts is just gaining this insight and then filling in the gaps. And we can go and make decisions about how to fill it and make suggestions to our clients as to how to optimize their spaces based on the results that we get from generative design. So we're going to look under the hood of our modification to the workspace layout script that came with generative design. We went through and made a couple of changes to it that serve our unique application of this for applying social distancing to classrooms and schools. So the biggest substantial thing outside of Python that we did for this was this, where we had to shift the visibility fan, which is the indicator that it throws onto the preview, to the interior of the desk zones to just make sure that it was actually sampling from inside those zones. And then the other modifications have to do with changing the direction of the vectors that it's using in the Python script. So this is the Python script, one of the Python scripts that we edited. It's and in here, once again, it's mostly just a change of vectors. So we're just changing the vector directions to make sure that it was sampling from the center of the desk and not from the edge, and not from the outside of the desk. Since in this case, the desk is actually the entire social distancing student plus desk module. Now we're going to talk about how this gets validated. So let's say we're just going to go with this layout. We can actually validate a layout that's been generated, the generative design tool, directly within our own tool, the workspace density planning tool here, or COVID-19 space density planning tool. That's also available on the Autodesk App Store. It's called the COVID-19 Space Planning Tool, or VA Plus COVID-19 Space Planning Tool. And we're going to go ahead and run this tool. This is a add-in that we've developed. It is modeless. You can do things in Revit while it's running. It pulls all of the families that it can find and enters them in here, and then you get statistics about the density of the rooms themselves line by line here. So let's evaluate this room then. And so in this case, it looks like this layout does pass. Actual social radiuses intersect, but they cannot intersect the human radiuses. So if we move this upwards a little bit, because that's what represents, the distance that's been entered, and we evaluate this room again, we can actually see that this is going to. So in this case, we have a result where workspace has been disincluded because it's overlapping with another human radius. And that's what the workspace density planning tool basically does, is it evaluates for collisions and also evaluates for distance to doors to make sure things aren't in door clear width. And it's looking at a number of factors as well, having to do with preferencing workspaces that are further away from doors. So that way, if you have a room where it's very narrow, it's going to pick the workspaces that are least likely to require occupants to pass each other. So that's how we get a layout for and validate a layout using the workspace density planning tool and generative design.
Hi, I'm John Resch, and I'm the BIM engineer at VA+. This is a preview of an add-in we're currently developing for linking Revit content into Infraworks Mobility Simulator. There are a number of benefits we have found to bridging these two environments, chiefly reducing the need to recreate or redraw content that already exists. By making the use of Mobility Simulator more accessible to Revit users, this enables mobility simulation to be used in more design decisions in existing BIM-centric workflows. And by bridging the concepts of mobility as a system into Revit, this also creates an interoperability path. Now let's take a look at how this looks from a usage standpoint in Revit. For ordinary rooms, you place a room controller family within the boundaries of the room. This tells the add-in to sample and categorize the room in order to model it as a mobility simulator area, and the add-in will create a segment between it and the nearest door for typical cases. Next, we're going to create a corridor using another type of the controller family. This is where things get exciting. Segments and joins are the backbone of a mobility simulation model, and our algorithm generates these segments from corridors, doors, and openings. Infraworks Mobility Simulator understands these blue segments as channels and green joins as courses. Next, we set up an elevator or lift stop for this floor plan's level by placing a lift type of the controller family and set the direction parameter for the direction of access. Then we create another corridor to represent the elevator lobby. Next, we create another corridor in the core of this tower model, which happens to have access to stairs. This time we place the stairs type of the controller family, which tells the add-in to sample the stairs inside the Revit room and generate a more complex equivalent structure in Mobility Simulator. We also add a vestibule for those stairs. For larger, more complex rooms, there will be a need to represent a sub-network that permits connections through the room between doors and subrooms. For this, we place one room type controller family near each door, and subroom type controllers within each subroom. This tells the add-in to analyze the room as both a corridor and as a destination, which can participate in the Mobility Simulator's demand matrix. The resulting lines and families can then be exported to a Mobility Simulator save file, populating it with mobility objects proportional to and representative of the mobility network of a floor plan's layout, so its usage can be simulated in greater detail.